Example 3, we want to verify that the equation is an identity. Remember that an identity will be something that is true for any angle. And we have a hint here that tells us that cosine of 2x is equal to cosine x plus x. So cosine of 2x, so this is what we would call a double angle, and it is the input for the cosine function. We're going to think of it, we can't change the input, but we can think of the input in a little bit different way. We can think of it as x plus x. X plus x, of course, is 2x. This is what we call a double angle. Cosine of 2x is equal to cosine squared x minus sine squared x. In order for us to prove that this is an identity, this is something that is true for any x, we're going to start with the left-hand side, and we're going to use our little note, our little hint. We're going to think about cosine of 2x as cosine of x plus x. Then we're going to use the sum identity for cosine, and we're going to rewrite this as cosine of the first angle times cosine of the second angle, which also happens to be x, minus sine of the first angle times sine of the second angle, which also happens to be x. So since they have the same exact input, cosine x times itself, we can write this as cosine squared x minus sine squared x. We will come to see this and call this one of our double angle identities, something that will always be true for any angle x. So we have matched our goal, and we can say that this identity has been verified. We want to verify that this equation is an identity. We have 1 plus cosine of 2x minus cosine squared x, and we want to show that that is equal to cosine squared x. We're going to start with the side that's more complicated, and we're going to show that we can get it to be equivalent to cosine squared x. One thing we have to be careful about is that we won't be able to factor this because this input angle is different than this input angle. So 2x as an input angle makes this a completely different type of term than just cosine of x. So we have to be careful there. What we're going to do is we're going to use the identity that we just showed, the double angle identity for cosine. We just showed in the previous example that cosine of 2x is equal to cosine squared x minus sine squared x. So we are going to replace that. We're going to bring down the 1, and we are going to replace just cosine of 2x with that identity. So cosine squared x minus sine squared x, and we're going to bring down the minus cosine squared x. And as soon as we do that replacement, we see that we have cosine squared x minus itself. So these two terms are like terms, and they have opposite signs, so they will cancel out. So we can bring down the 1 and the minus sine squared x. We're trying to get to cosine squared x. So let's remember our Pythagorean identity. Cosine squared x plus sine squared x is equal to 1. And we want to replace 1 minus sine squared x with something that is equivalent to it. So we will subtract sine squared x from both sides of the Pythagorean identity. And what we see is that cosine squared x is equivalent to 1 minus sine squared x. So instead of writing 1 minus sine squared x, we're allowed to replace that with its equivalent form, cosine squared x. So using that Pythagorean identity, we see that the left side has now reduced to be our goal, cosine squared x.